Our natural base of E can be very important when we are trying to calculate continuous interest. The formula that is used to talk about continuous interest that's compounded is going to be P, E, R to the T, where P is our principal amount, what we're starting with, R is your interest rate, and T is your time. So two examples here. If we start and invest $15,000, that's going to be our principal amount, so 15,000. E is going to be your base, and RT, so our rate is 7.75%, so our rate is going to be 0.0775, and we would like to know what this is after 10 years. So at this point, you are going to go to your calculator and type that in so that we can find what our value is, and our value is $32,558.88. So you at that point in time have more than doubled. Moving on to the next one. So as long as we know 3 of the 4 pieces, we can always find the extra one that we're missing. So in this case, we know a little bit of different information. We still know our principal interest or investment. We know $20,000. We're still going to have E. Our interest rate is 3.7, so we're going to have 0.037. And we don't know when what our time is. We want to know when the investment will double. So if I'm starting with 20,000, I want to know when it's going to be 40,000. So if I am starting to solve this exponential equation, I'm going to divide by 20,000 and I'm going to get 2. That's because we're trying to get double, essentially. 2 equals e to the 0.037t. We're going to go and rearrange and use logarithms. So the natural log of e, natural log of 2 equals 0.037t. The natural log of 2 is 0.693. So once I divide by 0.037, I'm going to realize that that's in 18.73 years. So almost 19 years later, if we're starting in year 2003 and I add 19 to that, somewhere in the year 2021, I will double. 0.7 of the year into 2022, I would double. By the end of 2022, I would have doubled.